Let's look at the changes in climate observed since the last deglaciation that we just talked about, going back to about 18 to 12,000 years ago. We talked about the CO2 increase, drop-off in glacier mass, and the changes in orbital forcing of this summer and winter radiations compared to the present levels. Okay, if we consider present level as 0 as the baseline, we had anomalies of up to 30 watts per meter squared increase in the summer, up to 20 watts per meter squared decrease in the summer. So during these increased summer radiation levels, you expect our monsoon circulation with ocean and land heat capacity contrasts and thermal contrasts and monsoonal circulations, right? So effective moisture 9,000 years ago compared to today, estimated based on various models and some evidences in cave speleothems, you know, those hanging things, stalactites, stalagmites, and stalactites. They actually leave a signature of groundwater minerals in them, which can be related to the temperature and humidity levels and so on and so forth. Okay, you can read that up. I didn't go into the details. So there is plenty of other evidence as well that there was a large-scale greening of the regions of the Middle East and Sahara and the semi-arid regions of Africa here in the central eastern parts. Had much more water vapor as well as much more greening, also over parts of Mongolia, northwest of India, and so on and so forth, parts of Iran, Middle East, etc. So also Japan, etc. So there are historical evidences of civilizations, for example the Mohenjo-daro, Harappa, that disappeared just about 2500 to 2000 years ago in northwest India, were related to the monsoonal changes as well. Okay, using models, the monsoonal circulation changes and so have been created. John Kutzbach led some of these amazing seminal work in the 1980s and so on, many nice papers, and he was the first one to argue that there is a very clear precession cycle in monsoon variability. Precession cycle is about 23,000 years ago. So in this record of North African lake levels and model simulations of moisture surplus in millimeters, you can see models are doing reasonably well. So they just, because the model is not run continuously because it's very expensive, especially going back to those time periods where we didn't have big supercomputers. They were running chunks of time, so they were running simulations of 18,000 years ago, 15, 9, 6, 3, and so on and so forth. And there is the semi-continuous record derived from African lake levels based on varves and other things, again proxies for lake levels. You can see that there was a huge wetting of these regions. So there was a greening of the Sahara around this time when the monsoon was strong, humidities were high, rainfalls were abundant, and so on. So the monsoonal circulation, which got set up around 10 million years ago after the Indian collision raised the Himalayas to a certain level, these circulations got set up. So you can imagine that when India was not attached, Himalayas were not there, you had different circulation. So now the summer circulation with the strong southwesterly winds that bring all this moisture create upwelling here. You remember all those good things are observed here, also have a precession timescale signal in them. So 20,000 years ago at the peak of glaciation, the species that are captured here in terms of the strength of the upwelling. So the upwelling changes temperature, and there are species like Globogerina buloides and I don't remember all the names. So they give you the proxy for strength of the upwelling, which can be used for as a proxy for the strength of the monsoonal circulation and hence monsoons. Okay, so you can see that that also reached upwelling species reached their maximum also around the same time. Here it is done in terms of the depth of the sediment core from some region over here, but the timing matches. Okay, so this is the precessional index going now 50,000 years ago to today to 50,000 years from now. Using Milankovich's formulas, we can easily do these. So this is how the tilt will change between 22.5 and 24.5. So we are here today at 23.4 or so. It's going to decrease, and then 10,000 years from now it's going to start increasing. We have come out of the maximum tilt 10,000 years ago to present. Okay, so you can see that the 65 north summer insolation change in calories per centimeter square per day. That's a strange unit to use, but nonetheless that also has changed over time. 10,000 years ago here that we talked about in the last podcast, where we are today and where we are headed into the future. Okay, so Milankovitch cycles actually work. So the changes in the rainfall patterns, humidity levels, and so on since deglaciation can be explained by orbital forcing at precessional timescale. So obviously that doesn't go away, right? That is always there because Earth is doing its thing, and the radiation distribution or the radiation levels over Earth are going to be changed by those orbital changes.